Second to last day of school, of class.
Bro, we having a test on this?
Yeah. Friday.
Wait, second.
Yeah.
It's on an exam.
I'm done.
Bro, we
I
don't know.
We're on.
Thursday.
Okay.
I'm done.
Guys, just trying to talk.
Listen.
Let the man speak.
Page 116, section 5.1. We actually have 2 sections tonight.
Aw.
So, it's a little gift from me to you. Extra reading.
Thank you.
So, make sure you give plenty of time to do all this. Definitely could be a quiz tomorrow.
I don't know.
Could you pull the blinds back
Our
there?
bio exam is like the Thursday, next Thursday.
Section 5.1.
Okay, so we have all next week for the family. Okay, so the reason last time last time. The reason was that for Thursday.
No, we have lessons
You'll have to get the essay sheet for that.
Tuesday. Then we have Biology Wednesday. Has Thursday.
More of them outside.
Exam review Friday.
Okay, my
Well, I didn't know
turn.
we were doubling up.
Bennett, stop talking.
We have a lab on Wednesday.
Yes, the last class is tomorrow, lab on Wednesday,
Great.
Thursday biography, Friday test.
I think we should X out the lab and have an
Exam review Monday and Tuesday, Wednesday.
Exam is Thursday.
Is it exam or do you whatever you call it?
Do we have a bonus point for the exam?
Some points, not as much.
Like 25.
Are we gonna have bonuses on the exam like we do on the test? Like
Yes.
that bonus sheet?
Okay, you ready?
I am ready. This camera is filming you.
Up here now. All right. These 2 sections we talk about human effect on the environment, conservation efforts, things we can do to improve the environment. The first section talks about biodiversity. What does that word mean, biodiversity? The variety of life in an area determined by the number of different species in that area. A place like New York City probably have a low biodiversity. There's not a whole lot of different species living there. There's some. Lots of humans, but humans is only one species. You know, you have rats, you have some plants, and a few trees and stuff. But biodiversity is great in an area that's like woods. The wilderness has a bunch of different species. Having great biodiversity makes an area more stable. Biodiversity increases the stability of an ecosystem and contributes to the health of the biosphere. The more organisms you have in an area, the better off the area is. The easier, the more change it can survive. If the area changes a bit, there's a lot of different organisms that can, move into different niches and stabilize the area. If there's not a lot of biodiversity and the area has some change, organisms can go extinct pretty easily. Here's a chart showing the bird species diversity in different locations. And as you go from green toward blue, you can see the diversity increases. Why do you think we have greater diversity in Central America than we do, say, up here in Canada?
Too cold.
Temperature. I couldn't hear what y'all said over there.
Warmer.
Warmer, yeah. That's correct, yes. The warmer it is, the more photosynthesis you have going on, the more food there is at the bottom of the food chain, and then the more species you can support. And so we always see that as you get closer and closer to the equator, there's a greater and greater diversity of species. The variety of ecosystems present in the biosphere is called the ecosystem diversity. We already studied ecosystems. You know, there's deserts and tundra and grassland and forest, tropical rainforest and such. That's refers to the ecosystem diversity. Not only do you want to have a lot of species in an ecosystem, you want to have as many ecosystems as you can. That gives organisms different places to live. Now, why is biodiversity important? That's what it goes into next. Well, one, biodiversity allows us to have different genetic traits that could possibly be used by humans. For instance, almost all the bananas in the world are the same species. Did you know that? There's not a lot of species of bananas. Almost all of them are. If you buy a banana in Georgia or California, you're buying the same species. That's a low diversity. Here's the problem with that. Let's say there's some kind of disease that goes through banana plants. Well, if it's a disease that affects that species, you could lose your entire banana crop. There might be no bananas. If you have a bunch of different varieties of something, if there were a bunch of different varieties of bananas, then a disease could run through one and you would have others that you could use instead. That's a genetic diversity. So you want that. And so that's something that's helpful. If you have more diversity, you're not going to run the risk of losing something. Medicines. Most of the medicines that we have in the world are from plants. Did you know that? From plants, and there's a good amount from fungi, and there's some from protists. But plants are where we get most of our medicine. Aspirin comes from a certain type of plant. As we lose the diversity, as the rainforests are cut down and such, we're losing a lot of potential medications. And that's a problem. All the antibiotics we use nowadays. 100 years ago, half of people died from infections. Half. The reason why families used to be so big way back in the olden days, one of the reasons, was because you had a kid, you didn't know if it would survive very long because of infections. Now that they have antibiotics, that's a big cure of diseases. Not a lot of people die from infections anymore, just because of antibiotics. Have you ever got sick and doctor gave you antibiotics? Okay, you ran a good risk of dying had those antibiotics not have been there. So, and we get most of those from plants and from other species. So we want to keep that diversity high for our medicines. Plants provide oxygen and remove carbon dioxide from the atmosphere. We need plenty of plants to do that. Plants have processes that provide drinking water safe for human use. The book talks about this area of New York. An economic study determined that restoring the biodiversity in the ecosystem that filtered the water supply for New York City was less expensive than using technology to perform the same service. They have machines that can filter the water and make it clean for people to drink, but it's a lot more expensive to do that than just to let the plants do it. The natural way of filtering water is a lot better, and nature can provide a lot of things for us, and one thing is clean drinking water. And of course, a lot of people just like nature. If you like to hunt, or fish, or go to the mountains, peaceful, hiking, things like that, that involves the wilderness and nature, and we want to preserve that. A lot of people enjoy that. And we're quickly running out of area as the population keeps doubling. Every 40 or 50 years, the world population doubles. And every time the population doubles, you got half as much space as you used to. And so it doesn't take too long at that logarithmic growth rate that we studied already to run out of wilderness. And there are places, people really haven't been in North America for very long. People have been in Europe for a real long time. And you can see there, if you've ever been to Europe, a lot of places in Europe, there just is no wilderness left. It's all been cut down and removed. So, you know, we can kind of see what the fate here is going to be if we aren't smart and conserve our resources. There's just not a lot of wilderness left in areas that have a lot of people. Okay, so that's just kind of a quick run through 5.1. You'll have to read that tonight. Let's take a look at 5.2. These are threats to the biodiversity of the planet. Most of them come from humans. There is what we call a background extinction rate. Organisms go extinct at a fairly steady rate, just naturally, even without human interference. But with humans, if you put humans into the mix, the extinction rates greatly speed up. And I don't know if you've heard of mass extinctions. Do you know about mass extinctions?
Like the dinosaurs?
Like the dinosaurs, that's correct. That's a mass extinction. Big meteor comes in, hits the Earth, throws a bunch of debris up into the atmosphere. It stays up there for many years, blocks sunlight, trees die, plants die, and the large organisms that need a lot of food all die on the Earth. It happened pretty quickly. And this just shows a lot of the organisms that went extinct. This is pretty cool. Have you ever seen this? Let's see. That's probably right there. It's fun. Just a little chart in your book. I don't know why they don't just give me the chart and make me move things around. These are out of order. Anyway, these are the time periods at which on Earth that we know of, there's been 5 great mass extinctions. And these are some of the organisms that went extinct at different times.
Submit that, bro. I want
Want me
to
to
see
submit
if you're right.
Right.
Nice.
I got them right. Here's the one that killed the dinosaurs 65 million years ago. That wasn't the biggest mass extinction. That's just the most popular because we all know about dinosaurs. The biggest mass extinction was this one, 251 million years ago. 95% of species on Earth disappeared.
Nice.
95%. Well,
What killed those?
it was when the continent Pangea came together and all those continents hit each other. You know, the continents, continental drift, the continents used to be all spread out, and then they came together to form this big one mass, and then they came back apart. But when they all came together and hit each other, it caused huge amounts of volcanic activity, which blew a bunch of stuff up in the atmosphere, which kind of served the same sort of thing as a meteor hitting. It just blocked out a lot of sunlight and caused a lot of changes. So we lost a lot of species. Yeah.
Are there like fossils of that? Or how do
Oh, yeah.
you know? Okay.
Yeah. Oh yeah. Yeah. They got lots of ways to show that. If you look at the fossil record, you see a whole bunch of species in these rocks, and then just above it, hardly any. You know, most of them disappeared. And we see the same thing when the dinosaurs went out. Now, here's the thing that you probably didn't know, Tucker. Very rude. Lay down your head like that.
Sorry.
We're in another mass extinction right now.
Oh my God.
Just as powerful of one as the dinosaurs going extinct. Just as many species disappearing.
Good.
Did I tell you the other day that there's only about 10% of the fish in the sea left
Yes, you did.
from a couple hundred years ago?
They said our population is double.
What's that?
No, it's not us.
Human population is double. Yeah. But that's just one species. There's thousands of species going extinct due to human influence. And so we are actually in the 6th mass extinction right now. And millions of years from now, if there are still people around, they'll look back at history and go, oh, and there will be another one of these, and there'll be a picture of, who knows, manatees that went extinct.
What about polar bears?
Polar bears are endangered. So humans have caused these big extinctions, and how have we caused them? Well, there's a lot of different ways. One is overexploitation. Excessive use of species that have economic value increases the rate of extinction. Humans have hunted creatures, not just recently. This goes all the way back to the thousands or hundreds of thousands of years ago when humans expanded and spread from Africa all over all the continents. And wherever humans went, organisms went extinct. When humans came to North America, we quickly saw the extinction of the mammoths and mastodons because the humans hunted them all. And there's not very many large mammals left because we've hunted most of them. Here are some organisms that are in a lot of trouble.
What's a passenger pigeon?
Just type of bird.
So the pigeon flies in the passenger side.
I don't know the difference between a passenger pigeon and some other pigeon.
What is that little bitch? It's adorable.
An ocelot?
That flying pigeon.
Yeah, it's a wild cat found in the rainforest.
Mr. Willis,
Yes.
when we lived in California, there was someone walking with them on a leash.
An ocelot?
Yeah. We
Really?
walked up to it.
They did the mimicry of like a leopard or something.
Here's why we don't have one reason why we're
not.
one reason why we're missing. There's a lot less organisms are because we have such great technology nowadays. We can hunt very proficiently. Here we go. Look at these nets pulling up all these fish. You can imagine there's a lot less fish if that's going on in a lot of places. It's a guy with a lot of fish. Look at this. That's a man standing on top of a pile of bison skulls. Look at that.
Bison burgers.
Millions and millions of these things. You can imagine if this went on in a lot of places, which it did. This is an old picture. There's a lot less bison around than there were before these guys got there.
I was watching History Channel, and they said that like when buffalo billed, they were killing like 300,000 buffalo a day.
Wow. That is a lot.
That's ridiculous.
So imagine how many of those there used to be. Now, there's not as many.
You ever had a bison burger?
The main reason why organisms are going extinct, though, is not overexploitation. It's habitat loss. One thing that humans do, and it's just a byproduct of having so many humans, is they spread out, they cut down forests, they build houses and roads and cities, and you know, everywhere on Earth now that you see a road in a city, that used to be woods. And it used to have deer and things living in it. And it does not anymore because now it is city. So that's destruction of habitat or habitat loss. When humans expand and increase their numbers, they just clear out woods. And so there's a lot less organisms. This shows, they discuss on page 125, up here, Ellen Grace.
Yeah, please.
They discuss how if one organism in an ecosystem is affected, it affects everything in the food chain. There was, for reasons of pollution and overfishing, I'm trying to see what area this is. Off the coast of Alaska, there was a lot of fishing being done. And when you lose the fish, the numbers of whales are affected. I'm sorry, the numbers of sea lions are affected. When the numbers of sea lions go down, the number of killer whales go down, and so forth. The fish are part of the food chain. And so if you lose one group, it affects all of the rest, everything above it that's eating it. So, and another thing that you don't think about, if the fish are gone, the things that the fish are eating can multiply. And that can have other consequences that sometimes are good and sometimes are bad. Habitat fragmentation is humans come along and cut down forests. This is a satellite view of the rainforest. And these lines you see, the dark area is forest, and the lines you see are roads where logging trucks have come in, and they come out to the side of their roads and they cut down the logs and they take them back and they make stuff out of them and sell them. And you could imagine over time you're going to lose that forest. Here is an area of forest that has now become patchy. There's a patch of forest still left there. There's a patch of forest still left there. This is what we see when humans move into an area. You usually don't see all the forest cut. The forest is made into what we call fragments. And, you know, who knows? There might be something built here and something built here and a road going through there. And you may still have this fragment and you may still have that fragment, but fragments cannot support the biodiversity that a very large forest can support. There are some animals that need more range than this, and they just won't be able to live in there. So we call that habitat fragmentation, and that's what we see. We see it on the island here. There are still areas, a few areas with forest, but you know, the deer population on this island used to be enormous. There's only been people on St. Simon's you know, for maybe 70 or 80 years. Before the causeway, the only way to get over here was by boat, and it landed over by the pier, you know, over where Brogan South is, and that was the only way to get on. And so that village area was the only area that had a lot of people. Everywhere else on the woods was on the island was forest. And there was huge amounts of deer and wild boar and organisms like that. As humans have expanded all the way around St. Simon's, you know, the deer population has been pushed to just a few areas of the island. And the numbers, I'm sure, I don't know what the numbers are, but they're way, way lower than they used to be. And eventually, if the entire island is developed, you're not going to have any deer left. Pollution. Here's something called biological magnification. Biological magnification, if you put pollution in the water, even at very small concentrations, ppm means parts per million. If some chemical gets into the water at very small concentrations, what happens is it can move up the food chain. Algae, these producers can absorb some of the chemicals, and whatever eats the algae gets all those chemicals in their bodies. The chemicals are concentrated as you go up the food chain, because a lot of these chemicals that we use, pesticides and herbicides and things like that, are fat soluble. What they do is they get in the fats of the organisms and they stay there. And then when organisms are eaten by other organisms, it's now in the bodies of those organisms. And every step up the food chain, it gets more and more concentrated. So it started out at 0.00003 parts per million in the water, which isn't very much, but in the top of the food chain, the fish-eating birds had 25 parts per million. This was for a certain chemical called DDT. I don't know if you've heard of DDT before, but DDT was a pesticide, something to kill insects that used to be sprayed around back in the 50s. And all of a sudden we saw this biological magnification, and at this level, the birds, it actually wasn't affecting the birds themselves, it was affecting their eggs. And the birds would sit on their eggs, and the eggs would crack because of the huge amounts of poisons. The eggs weren't being constructed correctly. And we suddenly saw the population of eagles, bald eagles, in the United States drop tremendously fast. And some scientists looked at it, and we were very close to losing the bald eagle forever. And what they did was they figured out what was going on, and they banned DDT. This is the bottle it used to come in. No companies could make it anymore. And was one of the ad campaigns where they were trying to show that DDT was actually safe, and they'd spray it on people, and the people were smiling.
Did we watch a video on it?
Yeah, we did.
After that, they like die.
And now the people, because again,
Just smoke.
the concentration, I mean, this is a huge concentration, but these people aren't in it for very long. But where you really see the effects is in this, what we call this biological magnification going up the food chain. So after they banned DDT, the eagle population recovered. And I think it's still a protected species, but it's not nearly the trouble it used to be. We have some of them around here. We already saw that.
No, it didn't.
Throughout my years studying whales, it's become increasingly evident that the problems they face are getting worse. When you spend a lot of time at sea, it's soon obvious that humans are devastating the oceans with toxic substances. We do this because of our false impression that the oceans are infinite.
We've seen this, haven't we?
Yeah, this is the
That's
same guy
what
that
this
did the
program
trash
is
movie.
about. We ask this fragile ocean to dissolve and absorb and purify.
Yeah, I showed y'all that whole video.
Yeah.
I think I have a stupid video. Yes.
Yeah.
Stupid video. Stupid and sort of sad.
Oh.
Hey, this is like the worst.
This is a mess. Look at us. We are covered with oil.
Hey, it's like I'm never gonna like get thing like what can
We
do?
have got positively putrid plumage.
Hey, you know, I got it.
What?
I got it. A way to prevent another disaster.
Oh, now you come up with the ideas. I'm going to save the world here. We look like the bird cast of Greece. I mean, look at us.
Like, hear me out, okay? I'm all like excited, okay? We get like all the birds together, like thousands of them, okay? Like terns and geese and mallards and stuff, and cranes and gulls, like everybody, okay? I'm all like, I
like the sound of this. Now, does this involve car windshields? Because let me tell you, I am a crack shot. I can hit a pedestrian at about 10,000 feet.
Serious,
I'm good.
okay? I'm all like excited, okay? We make like this big, humongous flying formation, and like in big black letters, we spell out, don't pollute. Isn't that look great? I'm all like excited, okay?
Don't pollute.
Yeah.
It's nice. It's a great idea. It's only one little problem, dear.
Okay, come on, this is great.
All this oil on our feathers?
Yeah.
We can't fly. We cannot fly.
Oh, God, I can't believe this, you know? I'm like,
Hey,
I'm all like excited.
No, come here.
Wait, you know?
Come here. I'll walk you to the rescue station. Don't worry about it. Why don't we have a worm up here? Hey, sure.
You know, they're collecting toothbrushes to help clean the birds in Gulf Coast. Do you know about that?
No.
Yeah. They're taking
I don't understand what crab doing.
It was just sitting there.
Another problem with human pollution is called acid rain. And this is a dead forest due to acid rain. Now, most people think that acid rain is just something that happens sometimes, and you have your normal rain, and then sometimes you have acid rain. It's not like that at all. All rain is acid rain. Because of human pollution, all rain has some acidity to it. Now, even without human pollution, there would be a little bit of acidity in rainfall, because the carbon dioxide in the air that's natural reacts with water to form carbonic acid. So rain by itself alone is slightly acidic. But here it shows, this is a chart of the pH of rainfall around the country. And due to a lot of people being in the Northeast, and also due to weather patterns kind of moving this way, you have the highest amount, the lowest pHs, which is the highest amount of acid in rainfall in the northeastern U.S. And these numbers up here are less than 4.3. 4.3 is, I don't know if you know, but neutral is 7. Neutral rainfall, neutral water has its pH of 7. And the natural amount for rainfall is about 6.5. So 6.5, if there were no humans, all rainfall would be about 6.5. With humans, the pH goes all the way down to less than 4, and if you don't know much about chemistry, you don't really know much about pH, but that's pretty acidic. 4.3 is pretty acidic. it's acidic enough to, like I said, kill forests, to make organisms that are in lakes and rivers not able to reproduce as much because of the acidity. It gives them less stuff to eat because plants don't grow as well. Algae don't grow as well in acidic conditions. And so it just makes the total number of organisms less. And if you look in lakes and rivers and forests, there are less of them, less organisms. These forests are less healthy than other ones that have not as much pollution. And again, you would expect California, because it's got a lot of people, to have higher acidity, but the weather patterns have a lot to do with this too. Yeah?
How acidic does something have to be before it like starts burning through stuff?
Like 2. Yeah, your stomach acid has a pH of 2.
Yeah.
So it's not going to really burn you. The pH scale is called a logarithmic scale because each step of 1 is actually 10 times as much acid. So something that's pH 6 has 10 times as much acid as something that's pH 7. So something that's pH 4, which some of this rainfall is, has pH 6 10 times, pH 5 100 times, pH 4 1,000 times, has 1,000 times as much acid as something pH 7. We call that a logarithmic scale. It's kind of like the Richter scale. Have you heard about that with earthquakes?
Yeah.
You know, something that's magnitude 7 earthquake is 10 times as strong as something that's magnitude 6. So it goes up pretty quickly. Every little step on that scale is a big step. Here's another thing that humans contribute to. It's called eutrophication. It's when we get fertilizers and soaps and detergents and things contain a lot of phosphorus and nitrogen and potassium. And what happens is when farmers fertilize their fields and then it rains, the rain washes the fertilizer off the fields and it goes into streams and rivers. And the streams and rivers will wash it into lakes and such. And you can run into a problem called eutrophication. What happens is, when the fertilizer gets in the water, the algae multiply like crazy. Because fertilizer grows the algae just like it grows plants. And the algae numbers can get enormous. And the algae can cover up lakes and streams. And then you have a problem. The algae bodies die, they fall to the bottom of the lake, they're decomposed down there, and the decomposition process uses up oxygen. And lakes like this, you'd think, oh, there's a lot of algae, there must be a lot of oxygen because they're doing photosynthesis. They're not. They become depleted of oxygen real quickly, and the entire lake can die. You can have massive fish kills in lakes like this. And all the fish you'll see after a lake goes through this process, you'll see just fish floating up to the top dead because they don't have enough oxygen. Look at this. This is a massive algae bloom. I think this is the coast of North Carolina. This is in the ocean. And all the green you see is from algae. And again, when rivers bring lots of fertilizers out into the ocean, you get this huge multiplication of algae. We call that an algae bloom. And look at this. These are all dead fish because there was so much algae that the amount of oxygen in the lake got too low. Fish need a certain amount, and when it drops below that, they die. It's not enough.
How bad does that smell, bro?
I don't know. I wasn't there. I just got the picture, but I'm sure it's pretty nasty.
I didn't know.
Here's another threat to biodiversity. The introduced species. One thing humans do is we can move from one place to another in boats and planes and cars, and we can move species around. And when species move from one place to another, you can have problems. Because where a species evolves, it has natural predators. But where a species if it moves to a new place, it may have no natural predators, and can multiply kind of out of control and kill other species. And one of the reasons why many species are going extinct now is due to this this non-native species introduction. This is showing kudzu growing over a little house. Kudzu was introduced to America from Japan. Graham, pick your head up, all the way up.
That's rude.
Yeah, that's very rude.
Kudzu.
I don't care if you can repeat the last few words. I want you to be looking up here to show me that you're paying attention. It's a way of you communicating with me, saying, yes, I am interested in what you're saying. Now, kudzu introduced to America, so on our roads, when we build a road and there's just dirt on the side, you can plant the kudzu and it would grow really fast and stabilize the dirt on the side of the road so it wouldn't wash away. Good plan, right? Well, in Japan there are natural insects and stuff that eat the kudzu and keep it from growing out of control. Here there's not. So these things, kudzu kind of grows out of control. It'll grow over trees and kill the whole forest. And if you ever drive around in Atlanta, you see this stuff all over the place. And it's driving some species to extinction. Mongooses were introduced to Hawaii to help control the rat population because rats were introduced to Hawaii. So they said, let's introduce mongooses to help control the rat population. And the mongooses started killing all the native birds. So it's kind of something that it's hard to predict what's going to happen when you introduce a new species somewhere. And so Hawaii, which had this huge native bird population, most of these birds are going extinct because of rats and mongooses.
Can I ask a question?
Yes.
Did anyone ever read Ricky Tikki Tavi?
Yes.
We all did.
My CB handle was the mongoose.
God, everyone was just patting me.
You know what CB handle?
No, Hawaii does not have snakes.
Okay, you can cut that off. We're going to continue.
Say goodbye.
Willis out.